This video shows how to run Bomber. Bomber stands for Bio-Optical Model Based tool for estimating water quality and bottom properties from remote sensing images. It is a software package developed in IDEA to be run in ENVI. The Bio-Optical model implemented in Bomber is based on the work from Lee et al., in which the above-water remote sensing reflectances is finally related to the concentration of water quality parameters such as chlorophyll, SPM, and CDOM, and to the properties of the bottom in terms of reflectances and bottom depth. After having added Bomber to the ENVI menu, a series of GUI will help you to set all the model parameters that are needed to parameterize Bio-Optical model and to run it on your imagery data. You can choose to run Bomber in both optically deep waters or shallow waters. First GUI will ask you a set of numbers which are needed to take into account of the air-water interface effects, as well as to relate the key quantity, which are the absorptions and the scattering coefficients, as well as the reflectances, to the remote sensor reflectance. Those numbers are usually taken from literature data. Key parameters for the model calibration is the absorption coefficients. The absorption coefficients are firstly asked in terms of pure water absorptions, in which you can provide to Bomber in terms of spectral data taken from literature data. With respect to the phytoplankton absorptions, you can model the dependence of the spectral absorption coefficients as a function of the concentration of chlorophyll A, according to different models, such as the one from Greco et al., as well as by providing to Bomber the specific absorption due to the phytoplankton. Similarly, Bomber will ask you the quantity to model the absorption due to the non-algal particles, as well as the coefficients which allow the users to convert the absorption of non-algal particles at a certain wavelength to the concentration of SPM. With respect to the absorption, Bomber then will ask how to parameterize the absorption to the color dissolved organic matter. This is a function of the slope that is asked in input, and in which you can also provide the dependence of the slope of CDOM with respect to the concentration of color dissolved organic matter. With respect to backscattering coefficients, Bomber also asks what is the contribute of the backscattering in terms of pure water. In this case, is need to pay attention with respect if you're working in fresh water or in salty waters. Then you need to set up which is the backscattering coefficients due to the chlorophyll, to the phytoplankton. And finally, which is the backscattering coefficients due to the non-algal particles in order to relate such kind of contribution to the concentration of SPM. In case of shallow water, you can also use Bomber to estimate the fractional cover of up to 3 substrates. For doing this, you need to provide to Bomber the reference spectra for the 3 coverage you are expecting to find in your study area. So you need to provide the reflectances of different kinds of substrates that in this case are related to the sand and to 2 types of aquatic macrophytes. After having set the model calibration, you need to provide to Bomber the starting values. Bomber, in fact, run the estimation of the unknowns based on optimization procedures. So you need to provide to Bomber the starting values of the unknowns in terms of concentration of water quality parameters, and in case of shallow water, of bottom depth and of the fractional cover of 2 of the 3 substrates. For doing this, you may refer to the knowledge of your in situ data or to literature data. Then a final GUI will allow you to set the constraint values to run the optimization procedures You can, of course, change those values, but you can also be happy with the default values. After having calibrated your model, you can run it by taking into consideration that the procedure is based on optimization procedures, so that the unknowns you have provided as initial value will change until you will find the minimum of the target function, which is shown in the slide. You can run Bomber on a single spectra by picking up the imagery reflectances. In red, you can see the reflectances as estimated thanks to the starting value. And then you can run Bomber so that the unknowns will be changed automatically until the unknowns will provide a reflectance which will be as close as possible to image reflectances which comes from your remote sensing images. The optimization procedures ends when this minimization is reached for the unknowns that are now the output of your procedure, which are plotted in blue. Of course, you need to provide to Bomber the input image, which is the remote sensing imagery expressed in terms of remote sensor reflectances, and where to save the output. Looking more in detail about these procedures, you can see from here that by running on Bomber, you will need to select the absorption properties we have seen earlier. You then need to select similarly the backscattering parameters, so the things we have seen in the previous video. And then you can pick up a spectra from your imagery data, as shown here, run it, and see the result of your optimization procedures. If you are happy with this finding, you can then also apply the procedure to every pixel of the imagery, and then you will be able to see the output in terms of an imagery data which looks of the same size of input image in terms of remote sensor reflectances, but instead of reflectance data, you will see a series of layers which provide you a map of chlorophyll, SPM, color dissolved organic matter, and in case of shallow water, also of properties of the bottom. So this is how the output looks like. This is the layer for chlorophyll A, this is the layer for SPM, for the color dissolved organic matter, of the depth of the bottom, and of the fractional cover of the three substrate type we have defined as input in the model parameters setting. Thanks for listening, and thanks a lot for your interest in our work.